Welcome to my lecture series. So in this video we discuss about case study on semiconductor applications. So already we know that semiconductors are materials that have electrical conductivity between conductors and insulators. So they are the foundation of modern electronics, enabling the functioning of devices such as smartphones, computers, solar cells and more. The unique properties of semiconductors allow for the control of electrical current, which is essential for the design of integrated circuits and other electronic components. So first, what is semiconductors? The semiconductors is that so semiconductors are typically made up of elements such as silicon or components like gallium arsenide. So these materials can be engineered to enhance their electrical properties by adding impurities, process known as the doping. So in a previous lecture series we discussed about these topics, and p-type and n-type, and the case study focus on that solar panels and other relevant applications like that real world impact, environmental impact, economic and social. So to further explore the importance and versatility of semiconductors, my students will present their case studies on various applications of semiconductors, including smartphones, LED lights, medical device and electric vehicles. So this will help them connect the theoretical concepts to real world technology and innovations. Thank you.
Greetings to everyone watching this video. Today I am going to take you on a journey through one of the most important discoveries that powers almost everything we use daily, from phones to satellites. The tiny hero here is a semiconductor. You may not see them, but the semiconductors are invisible engines that drive today's digital world. Without them, we wouldn't have smartphones, laptops, TVs, cars or even modern hospitals. They are the brains inside our machines. So what is exactly semiconductor? Why is it so important? How are they made? And what are the challenges and opportunities lie ahead in this field? Let's dive into this case study and understand how semiconductors are shaping the present, future and has brought us towards the moving future.
What are semiconductors? A semiconductor is a material that conducts electricity, but not as well as a conductor like copper and not as poorly as an insulator like rubber. It is somewhere in between. The unique ability allows us to control the flow of electric current in the ways that are incredibly useful. The most commonly used semiconductor material is silicon, which is found abundantly in sand. Other materials like germanium and gallium arsenide. What makes semiconductors so powerful is that they can be engineered to behave the way we want. They can switch the current on or off, amplify the signals, store data and much more. This flexibility is why they are in transistors, diodes, solar cells and integrated circuits.
Story and evolution of a semiconductor. The story of a semiconductor began in the early 20th century with the scientists studying the behavior of electrons in materials. But the real breakthrough came in 1947 when the scientists all Bell Labs, John Gurdon, William Shockley and Walter Britton invented the first transistor. This invention ever used in electronics. Before that, we used bulky vacuum tubes. Transistors were smaller, faster and much more reliable. In 1958, the integrated circuit IC was introduced, combining multiple transistors into the one chip. This allowed electronics to become smaller and more powerful. Then came to the microprocessor in 1971. The Intel 4004. It had just over 2000 transistors, but it started the computing revolution. Today, we have chips with over 100 billion transistors, with each smaller than a virus. Thanks to Moore's law, which predicted that the number of transistors on a chip could double every 2 years, wherever seen incredible growth in computing powers.
Types of semiconductors. Semiconductors are mainly of two types. Intrinsic semiconductor. These are pure forms of materials like silicon or germanium. On their own, they don't conduct electricity well. Extrinsic semiconductors. These are created by adding small process is called doping. If we add atoms with extra electrons, it becomes an n-type semiconductor. If we add atoms that create holes missing electrons, it becomes a p-type semiconductor. When n-type and p-type materials are combined, we create p-n junctions, which are the core of devices like diodes, transistors and solar cells. We also have compound semiconductors made from 2 or more elements. An example is gallium arsenide, which is faster than silicon, used in high frequency applications like mobile phones and satellites.
Of semiconductors. Semiconductors are used in almost every modern device. Consumer electronics, smartphones, laptops, tablets, TVs, cameras, and gaming consoles. In automobiles, modern vehicles have hundreds of chips for airbags, engine, sensor, and entertainment system. In healthcare, chips power diagnostic machines, wearable health monitors, and robotic surgery. Telecommunications, 5G towers, fiber optic networks, and satellite all rely on semiconductor. In industry, in smart factories, semiconductors control automation, robotics, and artificial intelligence. A single high-end smartphone can contain over 50 different semiconductor chips, performing various tasks.
As conclusion, to sum up, semiconductors are the foundation to modern technology. They transform the way we communicate, work, learn, and live. From the smallest wearable device to the most powerful supercomputer, all rely on incredible power of semiconductors. Understanding how they work and how they made us give a deeper appreciation of the devices we use every day. As technology grows, the importance of semiconductor will only increase, and this tiny invention changed the world once, and it is continuing to change, and it's